expressions. The question is, how can properties of operations be used to add expressions? Basically, this lesson is just another lesson giving us some practice on combining like terms is what it's going to boil down to. So that's probably good to get us back into the swing of things here. Let's go ahead and go to the next page and get started. So if we look at example 1, Delilah signs up for a health club and a rock climbing gym. What expression represents her total fitness cost after M months? So if you'll notice, if we look at their costs here, costs, we have initial fees and monthly fees. Initial fees, a lot of times they may be a one-time fee, like when you first join something. You know, sometimes it's an annual fee, a yearly fee type deal. But, you know, it may be just a one-time thing, and then, you know, they kind of don't charge you after that first time. They're hoping you'll just stay with it, and then you won't get charged as much. Or maybe it's a thing where they'll hope you keep going because you don't, if you cancel, then you'll have to pay that initial fee again if you rejoin later. Anyway, if we look at this, they made bar diagrams for these two things. They did this for the health club and for the climbing, rock climbing. And you can see the dark blue is representing their initial fee, and then the light blue is representing their monthly fee. So if you look at this, we can write an expression for each of those. They did over here. So for the health club, they came up with 80 plus 50 M, so $80 plus $50 a month. The rock climbing was 65 plus 40 M, so $65 plus $40 a month. So if we want to find the combined costs, means we're going to add those together. So to add those together, basically it's just looking for like terms. So the book actually rearranges these. They get their like terms next to each other. So the 80 and the 65, they get those next to each other because those are like terms. The 50M and the 40M, they get those next to each other because those are like terms. If you don't want to physically rearrange these, if you don't feel like that's helpful to you, then you don't have to do that necessarily. Okay, we can look at this. We can say 80 and 65. We're going to add those together. That's how they got the 145 down here, by adding those. And then 50M and 40M, they added those together to get the 90M. This is a little bit simplified compared to some of the stuff we're going to look at. One reason is that everything's being added. There's no subtraction here, so we don't have to worry about, you know, do we add the numbers? Do we subtract the numbers? Is my answer going to be positive or negative? But other than that, this is kind of the basis of what we're going to be looking at in this lesson. So the Try It, Sophia and Ollie each deposit $120 to open a joint account. They each make monthly deposits as shown. What expression represents the amount in the account after M months? So similar idea to what we just did here. The dark blue is their initial deposit. So they both put $120 in initially. And then you can see Sophia is depositing $150 a month. Ollie is depositing $135 a month. So we can make an expression here for Sophia's deposits. She's putting in $120 plus how much a month? 150. So that's 120 plus 150 M. So 150 times however many months. And then Ollie deposited 120 plus 135 a month. Make sure you're getting this down in your books, please, so you understand and you can follow along what we're doing. Okay, once we've done that, technically we can go ahead and start looking for like terms that we can combine together. The book is actually physically rearranging to get the like terms right next to each other, and if you'd like to do that first, you can. Okay, if we get them right next to each other, we can see 120 and the other 120, those are like terms. They're just plain numbers, constants, we call them. Also here we have a 150M and a 135M. Okay, so whether you actually physically rearrange them like that or not, we are going to look to combine like terms together. So the 120 and the 120 we could add together would be 240. 240, good. And then 150M plus 135M would be 285M. Good. All right, so what this means basically is that all together, this is giving us an overall picture of what's happening. Combined, they deposited $240 at the beginning, and then combined, they're depositing $285 a month between the two of them. So example 2, what's going to happen here is that they're saying that we have more than one variable, and you might say, well, we just had one with more than one variable. We just had something with an M and something with an M. That's actually, it's two variable terms, but not two variables. Two variables is meaning that we're going to have more than one letter involved in this problem. So Cindy spent $125 on ingredients for muffins and $92.40 on ingredients for bagels. Write an expression to represent Cindy's profit for M muffins and B bagels. So profit is we take our income minus our expenses. The book's doing this a little bit different way. I guess since you have theirs to look at already, I can just mention to you guys a different option for how we can do this, and then you can look at what they did. Probably what I would do on this problem is look at what all expenses they had. So their ingredients, they spent $125 for muffins. They spent $92.40 for bagels. So we could actually just combine those together first, see how much they spent all together for their ingredients. Which would be $217.40. This would be our expenses. Okay, that's what all the ingredients cost them. And then we could look at what our income was. Well, if you notice the muffins, they're selling for $2.40 each, and it says we're doing they sold M muffins. So you do $2.40 times M. The bagels, they're selling for $1.80 each, and we sold B bagels, so we could do $1.80 times B, however many bagels that is. That would be our income, is what that would represent. And again, for profit, we do income minus our expenses. So we would take that minus the $217.40. And you'll notice this is actually the same answer that the book has, other than they just put 217.4 instead of 217.40. Since we're talking about money, I'll go ahead and keep that 0 in the hundredths place there. The book is basically looking first just at muffins, then at bagels, and then they're combining them together. But again, I'm not going to be picky about what process necessarily you guys use, as long as it's a valid process. There's different ways you can do these problems. So example 3, they are promising us more complex expressions here, and you can see the difference there. It does look more complex. We're adding these together. The parentheses they have there, we actually don't need those parentheses. It's basically just saying I have these three terms here, I have these three terms here, and I'm adding those together. But the parentheses don't really have to be around those. Basically, again, we're just hunting for like terms that we can combine together and simplify this thing. So if you'll notice, our first term has an x in it. And then we got another term that's got an x in it here. So the 1/2 x and the 1/4 x. Again, the book actually physically rearranges and puts them next to each other. We know before we add fractions we have to have a common denominator. So with the 1/2 x and the 1/4 x, common denominator would be 4. So the first fraction, we'll multiply those both by 2. So that'll be 2/4 x plus 1/4 x is how they got the 3/4 x. The rest of this, and anytime they're subtracting, if you guys remember, you may want to add the opposite there, make your two sign changes. Might make it easier for you to see the signs of these things. Then they got their y's together, so -2y and -2y. They added those together. They're working together to get -4y. And then we've got -3 plus 5. They're battling it out. There are more positives by 2. So basically subtract 5 minus 3 is 2. More positives, it makes it a positive 2. And again, the book writes the answer like this. If you wanted to, instead of a -4y, you could have plus -4y would also work. One thing about the answer, if you have your answer in a different order, that's okay, as long as your signs are correct. Basically, what you guys will see when you do these problems, answers generally, they'll have the variable terms first in alphabetical order, and then they'll have the constant last. So on this problem, x comes before y in the alphabet, and then our constant is at the end. So that's just a trend you guys will notice as we do these problems. So if we look at the try it, we're going to be doing some similar problems here. They want us to find these sums. The first thing I would recommend as an option for you, if it helps, would be any time on the subtraction you can add the opposite. So I'm just going to go ahead and go through real quick. Anytime on the subtraction, add the opposite. Now, this part here, the -5.48p, that's actually not really subtracting. I mean, we can add the opposite there, but it's really addition in between there, so we don't really have to do that. So I'm just going to go through all these real quick and add the opposite so it's set up for us here when we go through it in a minute. And we're going to try and look at all 4 of these here today. Okay, always 2 sign changes when we add the opposite. Subtraction to addition, and then the opposite of the number that's there. Alright, so let's go ahead and look at part A. So if we notice on part A, again, I went ahead and added the opposite on the subtraction part. The first term has a C. There are actually no other terms that have a C, so I'm just going to go ahead and bring that down. There's no like terms with it. If you want to mark it somehow so you know you've accounted for it, that's fine. Same thing. We have a term with the P. That's the only one of those as well, so we can go ahead and bring that down. That leaves us with 2 terms. And both of those terms are constants, so we will be able to combine those together. So to combine these last 2 terms together, we'll notice that they are like terms again. They're both constants. They don't have letters next to them, so we can combine them. One's positive, one's negative, so they're working against each other. So we can subtract. So if we take the bigger minus the smaller, have to do some borrowing here. And we get 64 and 80 hundredths, or 64 and 8 tenths. We don't really need the 0 at the end. And again, we have more negatives than positives, so we could say plus negative 64 and 8 tenths, or you could say minus 64 and 8 tenths, however you want to do that. And kind of like the book's done, we've talked about it a little bit before. If you want to have let's cut off part of my answer there. If you want to have parentheses around that, negative 64 and 8 tenths, just to make sure you don't lose that negative sign, that's fine. Okay, we'll look at part B. One set of like terms we have in this problem is the y's. We've got a negative 5y and a positive 5y. So negative 5y plus 5y, just like negative 5 plus 5 is 0, negative 5y plus 5y would be 0y. If we take 0 times something, it's equal to 0. So those basically just cancel out. You can put 0y there, but we don't really need it. So we can basically just say those cancel each other. So we also have two terms that have x that we can combine together. And in this case, they're different signs again, so we can subtract them. And basically, again, denominators are the same, so we know it's going to be something over 11. So if we just do 3 minus 2 is 1, and then the question is, which do we have more of? We have more that are negatives, so negatives win out here. So that would be negative 1/11 x. So our remaining two terms, we've got negative 3 and 5 5/10 are like terms. And so we can combine those. One's positive, one's negative again, so we'd be subtracting them. One thing we got to watch when we subtract these, we got to make sure our decimal points are lined up. The negative 3, I don't see a decimal point there, but we need to treat that as negative 3 and 0 tenths. If we put it under the other 5, we're treating it as just negative 3 tenths, which is not the same as negative 3. So we subtract, we get 2 and 5/10, and this time we had more that are positive, so that would be a plus 2 and 5/10. So this would be our answer for part B.